Hi guys, Mr. G here. In this video, we are looking at trigonometry, and this is a revision, of course, and we will be using past exam papers. And the whole idea behind this is so that you can get used to the type of questions that are being asked in the final exam, and so the standard as well. And then so that you do not, panic in any way when you get to write your exam paper. So let's have a look at this one here, 5.1 right away. You are given that x is 3 sine theta, y is 3 cos theta. You just have to find the value of x squared plus y squared. Straightforward, simple, 3 marks. So x squared plus y squared is 3 sine theta all squared plus 3 3 cos theta that, and this is of course 9 sine squared theta plus 9 cos squared theta. And really at this point you see 9 is a common factor, and then we know this identity here, that this is going to be 9 times 1, which is equal to 9. All right, so quite straightforward. Remember, this is these are the type of questions they will ask to warm you up on the trigonometry section. You know, you're always gonna start with statistics, question 1 or up to 2 or so. 3 and 4 will be an analytical geometry. 5 and 6 or 5 to 7 will be trigonometry, and then they finish you off with analytical geometry, or you finish them off. You always have a choice to make. Okay, so this one is pretty procedural thing, nothing difficult. Let's see this one here. You've got to simplify this expression. Okay, it's an expression because there is no equation sign. All right, sine minus x, and really this one, this is just basically grade 11 stuff. So they're quite been merciful to even examine you with something that actually is at a grade 11 level. So let's see what's going to happen. Let me just write it here. You've got an angle greater than 360. So you know you've got to reduce that and see what it goes to. You've got a negative angle there. They want to test and see if you remember that. And that simple reduction formula, you've just got to pay attention to the quadrant there, which you're going to fall in. And here, very simple, it's a co-function type of reduction. So I've got a Cartesian plane here, so I'll just write, all students take care. And I hope you know by now the cast rule, how things work around that. So what do we do whenever we have an angle greater than 540? Guys, remember, if you've got an angle greater than 540, this suggests that actually you have rotated here, gone 360 and beyond. So we must find the difference between 540 and 360. I think you agree with me, it is 180. Okay, so we see that, oh, well, this is just as good as having actually sine 540. It's just good as saying, well, this thing is just 180 minus x. Okay, and trust me, there is a mark for that. Now, guys, sine of a negative angle is minus sine x. Okay, so I'm gonna write here, I'm gonna put in brackets, and believe you me, this is so that I will not think that I'm saying this thing minus that thing, because that's where you guys actually tend to lose it as students. You are in a hurry when you write that. So where I'm going to get a negative answer, I'm going to actually put brackets around that. Okay. And as you can see here, cos 180 minus x is in this quadrant here, and cos is negative. So that's going to simplify to minus cos x. And then sine 90 plus x, sine is positive in the second quadrant, but I have to change to a co-function. Okay, that's sine x there. All right, now the next thing that I do is just to apply the reduction formula. I know sine 180 minus x, it takes me here, and sine is positive in that quadrant, so this reduces to sine x. So there's a negative here, so this negative should be here, and I must so multiply by sine x. Here is a negative and a negative, that's going to be a positive, so this is cos squared x. So what do I have here? I basically have cos squared x minus sine squared x. Wait a minute. Single trig ratio, single term. I've got two terms here. How do I put this into one single term? I hope you can see that this is a double angle for cosine. Okay, so this is cos 2x, and that's it. If you didn't see it, you could try this. I mean, you could try this. Well, this thing here, if you substitute either sine or well, if you substitute cos, then you're gonna, I mean, if you substitute for sine, then you're gonna have that into 1 minus cos squared x, and then you've got actually now this and this gonna be a positive, so you have 2 cos squared x minus 1. You can see again that's a double angle and stuff like that. But I'm hoping, since you get formula sheet and all that, I'm hoping by at this point you would have actually figured that out. So 6 marks in the bag. I want you just to notice how big of a section is trigonometry towards your final paper. This question alone is 5 marks, and there's another question after this. Okay, we're gonna go through this together. Okay, so let's look at this one. In the diagram below here, you've got a point. Yeah, and they like doing that, not giving you the solution to that. At this point, guys, you need to be very careful. If you're gonna find x and p, know that they've got to be negative. Your p has got to be negative. Your x has got to be negative, because you're in the third quadrant. This is the negative x-axis. This is the negative y-axis. Okay, so you've got to pay attention to those kind of stuff. So of course here we're going to just use our definition. We know sine is opposite over hypotenuse. Okay, so quatre. So what this means, then we can take this whole thing and plot it here and just fill up some information here. You know, you always draw your right angle towards the x-axis. And so opposite, if this is my alpha, this is opposite. So that means this is P. Well, it makes sense. There it is. And then what I'm having here, hypotenuse, that means this side here is actually 1 plus P squared. That's what it means, guys. So show that x equals to minus 1. We know we've got to use Pythag here. X squared plus y squared is r squared. And then I'm looking for this thing here. And then what is my y? P. So even if you said minus p, that's fine. It's still going to be positive because you are squaring everything. And if I square this, I just hope I'll do it anyway. There it is. This is x squared plus p squared. And this thing here is just 1 plus p squared. All right. And then you can see this thing is going to take care of that. And so x squared equals to 1. So x is actually plus or minus 1. So we choose obviously x equals to 1, as I said, because we are on the negative x axis. Okay. Very simple, straightforward again. Then we move on, guys, and we are now going to look at this one here. Cos 180 plus theta has to be written as a, let's see, in terms of p in its simplest form. So first of all, I must reduce this thing, 180, not theta alpha. Yeah, we use a lot of theta. Yep. So I've got to reduce this first to minus cos alpha. Okay. Then minus cos, I know is adjacent, okay, over hypotenuse. So then this thing comes, so the x there, we just calculated it, is minus 1. Okay, I'm going to put in minus 1, and my r, not r squared, but r is that, and that's p squared. Okay, and of course this thing, here it is just 1. Okay, because this negative will do away with that, over this 1 plus p squared. And that's the simplest form that you can get to at this point. Finally, guys, let's look at 5.3.3 here. For which values of x will this identity here, or will this expression, expression be undefined? So whenever that happens, you need to analyze your expression. Whenever you have tan, then you know that tan x, okay, is sine x over cos x. And this thing will be definitely undefined if cos x is equal to 0. That's the first thing. And then what makes cos x to be 0, guys? If you look at the cosine graph without even solving for general solutions, and I like the fact that they have given you an interval. So right here is 0, right here is 90, right here is 180 and minus 1. So basically, we know that this thing is going to be 0 here at 90. So cos 90 is 0, okay? And that's yeah, that's got to make some sense because of that. That's the point that we are talking about here. That one is 180. Cos 180 is defined, so we don't have a problem with that, okay? Cool. Now, we've got to also look at the denominator. Let's look at the denominator. In the denominator, we don't want this thing to be 0, or we know if this thing is 0, then this thing will be undefined because division by 0 is undefined in mathematics, okay? So then you can see that sine squared x is 0, and so sine x is 0, and of course plus minus does not matter at this point because you never get a positive or a negative 0, okay? 0 is very neutral. So when is sine x 0, again in this interval, it will be a good idea to just have a rough sketch of the graph. This is 180 and that is 0. When is this thing 0? We can see it is 0 at 0, it is 0 at 180. So right here and then we can tell if x is 0 and if x is 180, and finally we figured that one there, if x equals to 90, we might have a problem. Here, 90 does not cause a problem in the denominator, but it causes a problem here with tan because you're gonna find yourself having to divide by a 0, and that is undefined. So what are the values of x, guys? Here are the values of x, okay? If x is 0, 90, and 180, we are surely gonna have a problem. The identity will be undefined. Straightforward, that's how easy it is. Finally, now let us go ahead and prove this identity. 5.4.2. My word, I think I forgot 5.3.3 here. But this one, guys, it's pretty easy, really. If you want to show that cos 2 alpha can be written as that thing there, you just got to use the identity and say, well, cos 2 alpha is, I think because we are given sine alpha, it will be much straightforward to use the fact that it is 1 minus 2 sine squared alpha. And all you have to do is to actually substitute. You will see if you substitute this thing over this thing here, okay, and you square that, this is just 1 minus 2 p squared over 1 plus p squared. Then you just take your LCD and then combine these fractions, you will get this answer. Quite straightforward, okay? So let's quickly now prove this identity. I have 2 tan x minus sine 2x over 2 sine squared x. This is tan x. So we know identities will always have two sides. You will have a left-hand side and a right-hand side, okay? Now, the important thing, the critical step for me here is choosing which side to work with. If you look at the right-hand side, it is very simplified. So there's too many options to try and make it look like the right-hand side. I mean the left-hand side. So it's pointless to really look at that. So this is your required to prove statement. And then you got to write your aim. So how are you going to go about this? Are you going to move left to right or right to left, or simplify both left and right at the same time? So in this case, for me, really, I think you should agree with me. It is very easy if I move from left to right, okay? So the first thing that I'm gonna do here, I'm gonna break sine 2x there. So I've got 2 tan x minus this thing should be, so I'm working with my left-hand side, 2 sine x cos x. You know the double angle identity by now. This is all over 2 sine squared x. And then you can see that you can actually factor out the 2, okay? You see that you can actually factor out the 2. So if you factor out the 2, you have 2. Maybe let's also simplify that tan x and have sine x over cos x minus sine x dot cos x. As a matter of fact, that could be a bad idea, because I might as well think about eliminating everything and be left with that. But in any case, that's okay. Let's simplify. Let's keep on simplifying. That, okay, this over 1, and then I've got 2 sine squared x here. So you can see that thing falls off. So we are okay. Now I've got to use the LCD method here and simplify this thing, okay? So what happens in the numerator is that cos x is the LCD. So I'm going to be left with a sine x here, okay? Then I'm going to have minus a sine x times a cos x and a cos x. So I'm going to have cos squared x. But remember, I'm dividing this thing by sine squared x. I'm dividing this thing by a sine squared x. So I'm going to continue somewhere here, guys, in red so that you can see that. Now, I'm left with what? In the numerator, I'm now having sine x. Okay, I can actually factor out sine x because I see it's a common factor. And I'm going to have now 1 minus cos squared x. You can see that. And this is all over what? Cos x. But now I was dividing, so now I'm multiplying by 1 over sine squared x. Then you realize that, oh, wait a minute, here's my tan x, okay? There's your tan x, and this thing is actually equal to that thing. So at this point, really, for me, it's immaterial. That thing is the same as that thing. I mean, you know this thing is sine squared x, okay? So what's the big deal, really? So you are left with sine x over cos x, and this thing is tan x, and it's exactly what your right-hand side is. So the key secret in proving identities, straightforward. Choose a side that you are able to work with, the one which is not oversimplified, okay? And the one that you can do some work on than actually going for a side which now is more simplified and you've just got too many options where you'll end up confusing yourself. Okay, guys, I hope this has brought some clarity of thought and you are able to now solve some problems. Try out those problems on your own. Let me just say, don't use past papers as a way of studying. Use them as a way of revision to test yourself if you know your stuff. Okay, cheers.